Okay folks, in this video I'm going to explain to you how to answer questions in which you have to explain the effect of drag. It's the worst answered questions in this section, so we really need to pay attention to this. Drag is a frictional force you experience when you're in a fluid, so if you're passing through air, as we all are in this atmosphere, or if you're passing through water, you will experience drag. If you're in a vacuum, there is no drag. Drag increases when velocity increases, and increases when the cross-sectional area increases. So there are the two reasons why drag increases, and you will get asked questions to explain why the velocity of a body changes when the drag changes. So these explain type questions, they're typically worth a lot of marks, and what you have to do is you have to say, why does the drag change? So for instance, the velocity increases, therefore the drag increases, and what effect does this have on the resultant force? Typically, if the drag is increasing, the resultant force is decreasing. So a couple of examples for this. Explain how the velocity of a skydiver changes. So we have to explain how the velocity of a skydiver changes. So originally, his weight is going to be constant. Therefore, he speeds up. So he speeds up, so velocity increases. Therefore, his drag increases. Therefore, the resultant force decreases. The resultant force decreases until you get to a point where the resultant force equals zero, and if the resultant force equals zero, by Newton's first law, the velocity is constant. So essentially, when he originally jumps out of the airplane, the only force acting on him is his weight, as shown in this diagram here. But as he speeds up, the drag increases until you get to a point where the drag and the weight are the same, in which case there is no further increase in the skydiver's velocity. Now, so the way you draw this in a velocity time graph is at the start he accelerates towards the ground with an acceleration of gravity which is equal to 10 meters per second squared. So that would be, at the start it's a relatively straight line, and the gradient of that line is 10. Now, but as the drag increases, the resultant force decreases, which means his acceleration decreases, which means it levels out. At this point here, where it's straight, that is terminal velocity, and that value there is about 56 meters per second for a human being jumping out of a plane. At this point here, the skydiver might choose to open his parachute. Now, just before he opens his parachute, this is what the scenario is going to be. The drag and the weight are equal and opposite. If he now opens a parachute, what happens is his cross-sectional area massively increases. So what this has the effect of doing is, well, at that velocity his drag then will massively increase. The drag will increase. Now what's happened is, the resultant force is up. At this moment now, the resultant force is up. So if the resultant force is up, that means the acceleration is up. And if he's got a velocity which is going down, an upwards acceleration will cause him to slow down. So for instance, his velocity at this point in time is 56 meters per second. If, say for instance, his acceleration is now, so his velocity is in the downward direction, so if his acceleration is in the upward direction, we must make that a negative. If his acceleration is minus, I don't know, 10 meters per second squared, well then what's going to happen is he's going to slow down. The minus is going to mean he's not going to speed up, but he's going to slow down. And so what's going to happen is he will slow down until he reaches a new terminal velocity. Now, why is it he reaches a new terminal velocity? Well, if you consider this diagram here, what happens is as he's slowing down, the velocity is decreasing, and therefore the drag is decreasing, until you get to a point now where the weight, this guy, and the drag are the same again. And once this happens, you're now at a new terminal velocity. And that terminal velocity is, I don't know, something like 2 meters per second. And that's safe enough to hit the ground, and he hits the ground at this point, and there's a further deceleration on hitting the ground, and that is due to the reaction force of hitting the ground. So at the instant he hits the ground exerts a reaction force up on him. It causes another negative acceleration and takes him from this velocity down to stationary. Next question. Explain how the acceleration of a hot air balloon changes over the first minute after being released from the ground. Okay, so we've got a hot air balloon, and we're going to call the upward force on it the upthrust. As we said, that's called upthrust. So, what is the question? The question has asked us to explain how the acceleration, so not how the velocity has changed, but how the acceleration has changed. So, originally what's going to happen is the resultant force, so originally the resultant force is up, and therefore, the resultant force is up, therefore, acceleration in the upward direction. Therefore, the velocity increases. But as the velocity increases, the drag increases. So therefore, the drag increases. As the drag increases, the resultant force is now, it's getting less. It's not as big as what it used to be. It gets less. So the resultant force is now not as big. It's a little bit smaller. But if the resultant force is smaller, that means that the acceleration is not going to be as big up, because it's going to be smaller. So I've specifically answered not how the velocity changed there. I needed to talk about how the velocity changed to talk about how the drag changed, but I've specifically talked about how the acceleration changed. Essentially in all these questions, what you have to do is you have to state either the velocity increases, therefore the drag increases, or the cross-sectional area increases, therefore the drag increases. So state which one of these is changing. Relate that to what's going to happen to the drag. Relate that to what's going to happen to the resultant force. And then you can relate that either to an acceleration, the acceleration will get less, or you can talk about if we'll eventually reach a terminal velocity. Okay, best luck at your study.